All right, number one. Was not ready here. So 3x divided by x minus 2. I need to know the domain. Actually, I already worked this one. So you want to see what makes the bottom equal 0. So what minus 2 gives you 0? It's 2. So it can't be 2. So the domain's going to be everything but 2. So you're going to do from negative infinity to negative 2, union to infinity. So I'm going to do negative infinity to 2, union 2 to infinity. Okay. Nice work. All right. So in number 2, find the domain. You just want to see what makes the bottom equal 0. Okay, so you're going to set the bottom equal to 0. So x squared minus 49. Well, basically it can equal 0. That's the difference of 2 squares. You can do x plus 7, x minus 7 can equal 0. So x plus 7 can equal 0. X minus 7 can equal 0. Subtract 7, x can't be negative 7. Add 7, x can't be 7. So these are your two restricted values. So the domain of h of x is restricted to, and so on this one, it can't include negative 7. So you go negative infinity to negative 7, union from negative 7 to 7, union 7 to infinity. Okay, so it's restricted there. It can't be negative. This doesn't include negative 7, doesn't include 7 there. So negative infinity to negative 7, union negative 7 to 7, union 7 to infinity. Okay. Fantastic. Now let's go to the next one. 3, we have h of x equals 16x squared plus x divided by x squared plus 4. So we want to see what makes the bottom equal 0. We talked about this in the notes yesterday. I could prove it to you. X squared plus 4 cannot equal 0. So subtract 4. X squared cannot be negative 4. Square root, plus or minus. Take an I out. The square root of 4 is 2, so 2i. Now, here's the thing. I solve it, try to find out what makes it equal 0, and it gives me an imaginary number. So therefore, what this means is no real numbers would make this 0. And so because of that, there's no restrictions on the domain. There's no restrictions. No restrictions on the domain of h of x. Next one, I don't need to really, I'm writing it down on the paper, but you don't need to write it down. As x approaches, this arrow means as approaches, and this negative 4 means that's the x value, and the minus means negative 4 from the left. So you've got the minus side and the plus side. The minus side means the left. So this means as x approaches negative 4 from the left. So as x approaches negative 4 from the left, so as I'm coming from the left, approaching negative 4, where's y going? Where's y going as I go towards x that goes towards negative 4? Y is going up forever, so y is going to infinity. So f of x would be going to infinity. So as x goes to negative 4, as I approach negative 4 from the left, where is y going? Y is going to infinity. X approaches infinity. Okay. One, as x approaches negative infinity. So that means as I go forever to the left, as I go forever to the left, where is y approaching? So here, y is approaching 0. So f of x approaches 0. So it'd be 0 here. Okay. 6. Let me pause real quick. So on 6, as x approaches negative, or as x approaches 2 minus. 2 minus means as x approaches 2 from the left. So as I'm approaching 2 from the left side, where's y going? Negative infinity. So it'd be negative infinity. All right. So as x approaches negative infinity, so as I go towards negative infinity, where is y going towards? Well, y is going towards this horizontal asymptote, which is at 3 for on mine. So it's going towards 3. It's approaching this horizontal asymptote right here. As I go forever to the left, it's approaching this to be 3. All right, next question. Find the vertical asymptotes. Okay, so this one's a little bit easier here. So the first thing you want to do is you want to simplify it if you can. Okay, and to find the vertical asymptotes, you want to make the bottom equal 0. So make the bottom equal 0. So x plus 6 equals 0. Subtract 6, x equals negative 6 is your vertical asymptote. So r x equals negative 6. And there's no holes. Find the vertical asymptote in the corresponding holes. So this one is going to have some issues. So h of x equals x divided by x times x minus 7. So what happens here is something cancels. The x's cancel. So you're left with 1 divided by x minus 7. Okay. And so there's going to be vertical asymptote's going to come from this. This is going to create a vertical asymptote. So x minus 7 equals 0. 7. So vertical asymptote's x equals 7. And then there's going to be a hole created by this. There's going to be a hole created by what cancels. It's what makes that equal 0. Just be x equals 0. So you're going to have a hole at x equals 0 and a vertical asymptote at x equals 7. So for the answer, there's a vertical asymptote is x equals 7 and the hole at x equals 0. Okay. 10. Find the vertical asymptotes and holes. So on this one, if you remember, okay, if you ever have a squared quantity plus a number, the bottom can never be 0. So there's going to be no discontinuities on this one. Now, I'll prove it to you real quick if you want me to, but there's going to be no discontinuities, and I'll prove it to you on this paper. So if you set the bottom equal to 0, x squared plus 5 equals 0. Subtract 5, x squared equals negative 5, and then the square root, and you get x equals plus or minus I squared of 5. You don't have any real numbers, and so there's no way that could be 0. So there are no discontinuities. Continuities. Probably spelled that wrong, but that's all right. All right. Let's try 11. Find the vertical asymptotes and holes. Okay. So this one's going to be interesting. X squared minus 144 divided by x minus 12. So I'm going to factor the top and the bottom. X plus 12, x minus 12. It's a difference of 2 squares divided by x minus 12. That cancels, so I'm left with x plus 12. And so there's nothing left on the bottom. So there's no vertical asymptote because there's nothing left on the bottom. But there is a hole. Okay, and there's going to be a hole right there because something canceled on the bottom. So x minus 12 equals 0. Add 12, there's going to be a hole at x equals 12. X equals 12. So There's no vertical asymptotes. There's a hole at x equals 12. Yeah. Here. All right, 12. Find the horizontal asymptote. So horizontal, you want to ask yourself which one has a higher exponent, the top, bottom, or is it a tie? So I've got 15x divided by 5x squared plus 8. So which one has a higher exponent, the top or bottom, or the tie? So you see, do you have a higher on the bottom? All right, so I do too. So the bottom has higher exponent. Bottom, higher exponent. So when it's the bottom, it's always going to be y equals 0. Okay, so in the bottom, so the horizontal asymptote is y equals 0. Okay. Y equals 0. Type an equation. Gotcha. All right, 13. Write this down. F of x equals 10x squared divided by 5x squared plus 6. Which one's got higher power, top or bottom, or is it a tie? See, this one's a tie, right? So when it's a tie, you do the leading coefficient in the top divided by the leading coefficient in the bottom. So you do 10 divided by 5, which is 2. So y equals 2. So it's the leading coefficient in the top divided by the leading coefficient in the bottom. The horizontal asymptote is y equals 2. Y equals 2. All right. 14, we have a horizontal. We've got h of x equals 18x cubed divided by 3x squared plus 4. Which one's got a higher power this time, top or bottom, or is it a tie? The top. Now, when the top has a higher power, there's no horizontal asymptote. No horizontal asymptote. So when the top has a higher power, there's no horizontal asymptote. So there is no horizontal asymptote. Horizontal asymptote. All right. 15. Use transformations to graph y equals 1 divided by x to y equals 1. So y equals 1 divided by x f of x equals 1 divided by x to g of x equals 1 divided by x plus h. So 1 divided by x is this one, where you have a vertical asymptote there, horizontal asymptote there, and you have a curve in the first quadrant and a curve in the third quadrant. Plus 8 to the x means you're going to do what to this? It's going to go left 8. What do you have, Dorothy? What do you have for g of x on this one? Oh, you're ahead of me. I can't keep up with you. And I didn't do this very well. So left 8. So it means I got to go left 8, 3, 4, 5, 6, 7, 8. So my asymptote's now going to be there. This is going to look trashy. And so I'm going to have the graph will be like that. So that will be my answer. Sorry, that looks trashy. So I'll go left 8. So it should be A. 16. All right, let's set myself up for success here. I've got y equals 1 divided by x. I want to transform it to, or let's do f of x, sorry. F of x equals 1. I want to transform it to g of x equals 1 divided by x minus 6 plus 2. So minus 6 to the x is right 6. It's going to be right 6. And plus 2 means up 2. So my original, remember, is vertical, horizontal. Got a curve there, curve there. So I'm going to go right 6 and up 2. So I'm going to go right 6 and up 2. So from this, I'll go right 6, 4, 5, 6, up 2. And so now my asymptote's going to be like that and that. So these asymptotes shift right 6, up 2, and they intersect there. So I'll be up in that area and then down in this area. So, oh, they didn't even ask me. Oh, is there 2 parts? Okay. So this should be horizontally shifted to the right 6 units and vertically shifted up 2 units. Oh, I got to write that down. I'm not going to write it down again. So right 6 and up 2, right 6 up 2. There we go. That's D. I'm guessing I'm about to get in some trouble here. Okay, so use transformations. The x squared graph is a special squared. I'll talk about that. G of x equals 1 divided by x minus 7 quantity squared. So 1 divided by x squared is going to be a special square graph. The asymptotes are still x equals 0, y equals 0, but they're both in the top 2 quadrants here. Okay, and so minus 7, that means right 7 because you're doing minus 7 from the x. So I'm going to shift this right 7. 2, 3, 4, 5, 6, 7. 6, 7, got them. So like that. And so like this, and then that. So it goes right 7 units. It's probably not too bad. All right, similar to that last one, can I fit this in here? 18 f of x is equal to 1 divided by x squared. G of x is equal to 1 divided by x plus 7 squared plus 4. So what does this mean? Left 7, up 4. So it's going to be horizontally shifted left 7 units and up 4, vertically up 4. And so left 7, up 4, that will give you A. And up 4, as I said, let's check that answer. Okay. I didn't go over the symmetry thing in the notes, so I'm going to take an L on this one. So I need to find f of negative x. So that means I plug in, anytime I see x, I plug in negative x. So 2 times negative x divided by negative x minus 2. And so that gives me negative 2x divided by x minus 2. And I've also got to find negative f of x. So I got to find negative f of x. So if I do negative f of x, that's going to make, I'll make the be negative times 2x, x minus 2. So it'll be negative 2x over x minus 2. So f of x does not equal f of negative x. F of negative x does not equal negative f of x. So this one's going to be neither. So this will have neither. So it'd be neither y-axis symmetry nor origin symmetry. Symmetry nor origin symmetry. Okay. Now I got to find the y-intercept. So for the find the y-intercept, make x equal 0. So make x equal 0. So it'd be equals 2 times 0 divided by 0 minus 2. 0 divided by negative 2 be 0. So it'd be 0, 0. So the y-intercept is 0. Intercept is 0. By the way, I could graph this too. X-intercept, make the top equal 0. So for the x-intercept, we make the top equal 0. So x-intercept, make the top equal 0. So 2x equals 0, divide by 2, x equals 0. So it's 0, 0. So the x-intercept is 0 as well. The x-intercept is 0. Find the vertical asymptotes. So vertical asymptotes, that's what makes the bottom equal 0. So I set x minus 2 equal to 0. Add 2, x equals 2. So the vertical asymptote, the equation of the vertical asymptote is x equals 2. The vertical tote is x equals 2. Okay. Horizontal, so you see which one has a higher power. It's a tie because 2x and x minus 2. 2x divided by x minus 2, it's a tie. So you're going to do y equals the leading coefficient at the top divided by the leading coefficient at the bottom. So y equals 2. So the equation of the horizontal is y equals 2. Y equals 2. Equation horizontal asymptote is y equals 2. Y equals 2. Okay, next we'll do plot points. So I'm going to cheat on this. So plot points. So I'm going to go to y equals. I'm going to type this in here. I'm going to go to math frac. And then I'm going to do 2x divided by x minus 2. And then do second graph. Okay, so I'm going to use the calculator. So x, and then f of x. So I've got negative 5, negative 4, 1, 5, 7. So negative 5 is 10 sevenths. Negative 4 is 4 thirds. 1 is negative 2. 5 is 10 thirds. And 7 is 14 fifths. So I'm just typing that from my calculator. Second graph. So 10 sevenths, 4 thirds, negative 2, 10 thirds. And they want a simplified fraction. That's where the math frac thing comes in handy. Using calculator. So I'm going to put there, make a little note. Okay. and then find. So basically, we're going to put all together here. So we have a vertical, let's see, graph. So we're going to do we have a vertical asymptote at x equals 2. Actually, I'm going to do the graph on the side over here. I'm going to do it over here. So we have a vertical asymptote at x equals 2. We have a horizontal asymptote at y equals 2. I should have been doing this the whole time. We have a y-intercept, and x-intercept is 0, 0. We have -5 is 10 sevenths. 2, 3, 4, 5 is 10 sevenths. So that's a little over 1. It's right in here. 4 thirds. So that's 1 and 1/3. Okay. -2. Whoops. -2. What? Let me see here. So I've got this going this way. And I got 1, -2. So 1, -2, that'll be down here. 5 is 10 thirds. 3, 4, 5. That's 10 thirds. So that's 3 and 1/3. And then 7's 14 fifths. So it's 14 fifths. So it's going to be going. You could look in your calculator too. So it just gives you a sketch like that. And that matches that. So let's see which one does that. It looks like goes through 0, 0. That right there. Okay, number 20. So we have f of x equals 8x divided by x squared minus 16. Now, by the way, you're welcome to type this in your calculator, math frac, or y equals, and then math frac 8x divided by x squared minus 16. Okay, but we got to check symmetry first. So I'm going to find f of -x. I'm going to go full screen on this. So f of -x means you plug in -x anytime you see x. And you see what that simplifies to. So it'd be -8x divided by x squared minus 16. And you've got or negative f of x. So that's just making it be negative times 8x divided by x squared minus 16. So I could just make one that I'll make the top negative 8x divided by x squared minus 16. Okay. Actually, notice on this one that f of x does not equal f of -x. However, f of -x equals negative f of x. I can't write this very well. These two are actually equal. So f of -x is equal to negative f of x. Okay, and so this means this has origin symmetry. I think there's, apologize. I spelled symmetry wrong. 2 M's. I knew it. So origin symmetry. And so this one has origin symmetry. I was going to show you on the graph. If you look at the graph, if you look in perspective from the origin, it's symmetric. From the perspective of the origin, the middle, it's symmetric. So that's why. So you can tell that by graphically looking at it. Okay, the y-intercept, you make x equal 0. Okay, make x equals 0. So f of 0 is equal to 8 times 0 divided by 0 squared minus 16. That'd be 0 divided by negative 16. So it'd be 0. You could tell by looking at the graph, it's the y-intercept 0. The y-intercept 0. So the y-intercept is 0. Intercept is 0. Now to find the x-intercept, you make the top equal 0. So to find the x-intercept, make the top equal 0. So that would be 8x equal to 0. Divided by 8, divided by 8, x equals 0. So the x-intercept 0. Intercept is 0. Okay. Now the vertical asymptotes. So vertical asymptotes. You want to make the bottom equal 0. So that's going to be x squared minus 16 equals 0. Okay, so which is x plus 4, x minus 4 equals 0. Okay, difference 2 squares. And so, by the way, I need to be drawing this stuff as I go. So the x-intercept and y-intercept is 0. So x plus 4 equals 0, x minus 4 equals 0. Subtract 4, x equals negative 4. Add 4, x equals 4. So you're going to have a vertical asymptote at negative 4. And a vertical asymptote at 4. So vertical asymptotes at negative 4 and 4. Pause this. So I plugged that in real quick. I typed in x equals negative 4, x equals 4. Horizontally, you ask yourself which one's got a higher power, top, bottom, or tie. In this case, the bottom has a higher power. So the equation of the horizontal asymptote, okay, which one's got a higher power, top or bottom? The bottom has a higher power. So when the bottom has a higher power, it's y equals 0. So you got horizontal asymptote at y equals 0. Now, plotting the function, this is where I would use the calculator. So plot points. So I've got x, and I've got f of x equals 8x divided by x squared minus 16. My x's are negative 6, negative 5, negative 1, 1, 6, 7, 6, 7. So I do use the calculator here. Use second graph. Okay, so I entered it as a fraction. So what I can do is here, I can do second graph. So negative 6, it's going to be negative 12 fifths. Negative 5 is negative 49ths. Negative 1 is 8 15ths. 1 is negative 8 15ths. 6 is 12 fifths. 7th is 56 33rds. So those are my points. So I'm going to do negative 12 fifths, negative 49ths, 8 15ths. 1 is negative 8 15ths. 6 is 12 fifths. And this one's 56 33rds. Okay, and I could start graphing these too. So I'm going to graph those points. Now you could tell by looking at the graph here too. But I'm going to graph those points. So I've got negative 12 fifths, negative 6, 3, 4, 5, 6, negative 12 fifths. So that'd be down here, negative 49ths. So that would be past negative 4. And so this one's going to go like this. And then next one's going to be negative 1 and 8/15. 1 and negative 8/15. 1, negative 8/15. So this one's going to go approach that one and settle here and then go back down. This other one's 6 and 12 fifths. So 12 fifths that's 2.4. So it's right there. And then 7 is closer to this, so it's going to go down to a little over 1. So it's going to go like this. So I'm looking for that type of graph there. So let's see what I got here. It's going to 0, 0, and it's looking like this one. Yeah, so that would be my answer. All right, this one, looking at the symmetry, I'm going to, well, this symmetry is not very inspiring. F of negative x, Macy, we have the same one. Oh, man. Squared plus 4. So you plug in negative x anytime you see x, but what's negative x squared? Negative x times negative x would be x squared. So if you notice this time that these two are the same, f of x is equal to f of negative x. Now I'll write this, you don't have to write this down, but I'll prove to you about the other one. Negative 7x squared divided by x squared plus 4. Negative 7x squared divided by x squared plus 4. So on this one, f of x equals f of negative x. So if that's true, you have y-axis symmetry. Could you cheat on this? Yes. Here's how you could cheat on this. Go to your calculator, press y equals, and go look at the graph. 7x squared divided by x squared plus 4. Look at this slow thing. Oh, man. Okay. So if you look at this, is that symmetric? Do you see how that's symmetric along the y-axis? So that's got y-axis symmetry. So I thought you just proved it. Yeah. Or no, I proved it did. I proved it did. Oh, yeah. But I'm saying if you didn't want to do all this formula stuff, you could tell by looking at that if you wanted.
What's the other one? How do you do the other one?
Origin. So origin. And also, I'll make a note. F of negative x does not equal negative f of x. So there's no, so it's got y-axis symmetry. So you could tell by looking at the graph. Okay, I'll try to, the y-intercept. So to find the y-intercept, you make x equal 0. Let's see. Okay, so f of 0 is equal to 7 times 0 squared divided by 0 squared plus 4. 0 squared 0 times 7, 0 divided by 4, 0. Now you could tell it's going to be 0 by looking at this thing too. Okay. Well, kind of. Trace. So it's, yeah. Yeah, they ask for just the actual value, yeah.
They're just specific on some stuff and then some
Yeah, the y-intercept. And kind of, I know when I teach Algebra 2, I try to get students to think the points. That's more of a Miss Mitchell influence by doing the coordinates instead of just naming them. But the x-intercepts, you make x equals 0. Now, Macy could cheat and tell me what the x-intercept is going to be here. Macy, what's the x-intercept going to be? Good. You are correct. I'll prove while she's right. Make the top equal 0. So 7 So you don't have to do all this. I'll prove all she's right. X squared equals 0. Square root, x equals 0. And I should be graphing this stuff, by the way. That's an L for me. The x-intercept and the y-intercept 0. X-intercept is 0. Vertical asymptotes. Now, we could cheat a little bit. Y'all remember yesterday? This is what Quade's talking about. Or we talked about yesterday. Make the bottom equal 0. Now, this time, I have x squared plus 4 equal to 0. Y'all remember playing this game yesterday? What can I square and then add 4 to it that will ever be 0? Nothing. It does not have a vertical asymptote. You know that from doing the notes and that type of expression. You know that from doing the graph. If you want me to prove it algebraically, I'll prove it algebraically. Okay, it's not going to have one because I do the square root and I get plus or minus 2i, which aren't even real numbers. So it's not going to have a vertical asymptote because there's no real number that makes the bottom equal 0. There is no vertical asymptote. Okay. Now, horizontal, which one's bigger, top or bottom, or is it a tie? So, has a higher power. Actually, on this one, was a higher power, top or bottom, or is it a tie? This one's a tie. So you do y equals 7 divided by 1. This would be 7. So y equals 7. I need to plot that 3, 4, 5, 6, 7. How did 6, 7? So it's going to have a horizontal asymptote up there. So y equals 7. And you have to do the equation here. So the equation of the horizontal asymptote is y equals 7. We'll look at that in a moment here. Now, plot points. You could use your calculator, MathFrax, your BFF on this. Okay. Dang, I'm going to waste another piece of paper on this homework. I debated on whether I should print out the originals, but I guess it helps to have y'all do this in there. So I go to MathFrac, or I've already entered it in there. So I go to second graph. So -5, 175, 29. So this gives you the exact value, so you could use that in your table. 7 halves, 3, 4, 5, 175 divided by 29, and 6 is 63 tenths. I could also plug that in, each of those into the equation, but that's just, I'm too lazy for that. Me and Ian don't have time to do that, so. And Chandler's got to get to his game, so he didn't have time to take a break from this game to plug all those in. 7 halves. 175 divided by 29. And then 63. Aw, man. Yeah. Okay, check answer. Excellent. And graph. Now, y'all know what the graph looks like. I should have been plotting those points. I need to have an idea. 175 divided by 29. That's 6.03. 1, 2, 3, 4, 5. 6.03. So that's over here. 4.5. And so it goes like that. 179. That's 6. 1, 2, 3, 4, 5, 6. That's up here, and they're getting closer and closer to 7. So it's going to be this one. 22 brings an interesting scenario because you want to simplify this thing first. What multiplies negative 12 and adds to 1? That would be x plus 4, x minus 3, divided by x squared minus 4, so it'd be x. Oh, wait, never mind. I was wrong. That thing will cancel. So nothing's going to cancel there. So we'll look at this graph. So x squared, you can type it in here, plus x minus 12. But you would want to factor it anyways. This one might have one of those slant asymptotes. Okay. Yeah, well, no. It's just got a lot going on. Okay. So symmetry, there actually is some symmetry there if you notice. It looks like it. F of negative x is equal to negative x squared plus negative x. Actually, I don't think that's going to have symmetry because the top negative x squared minus 4. So it'd be x squared minus x minus 12 divided by x squared minus 4. It's not the same thing as that because of that x.
Hubbard, when you have multiple asymptotes, does it want an x equals?
You'll put x equals, you'll put commas in between them, or commas. Yeah, so x squared plus x minus 12 divided by x squared minus 4. You just make one negative. So it's going to be negative x squared minus x plus 12. This one appears to be neither because none of these are equal. Okay. So to find the y-intercept, make x equal 0. So f of 0 equals 0 squared plus 0 minus 12 divided by 0 squared minus 4. Negative 12 divided by negative 4, which is 3. Oh, goodness. All right, so the y-intercept's 3. You could have saw that by looking at here. So the y-intercept is 3. Intercept. And I need to be graphing this. My bad. I need to be graphing this. So the y-intercept's 3. 1, 2, 3. Y-intercept is 3. Check answer. The x-intercept, so you make the top equal 0. And this is where the factoring came in. So x-intercept, make the top equal 0. So it's x squared plus x minus 12 equals 0, which is factored form. X plus 4, x minus 3. That's what factored form, so you're going to set each of those equal to 0. X plus 4 equal to 0. X minus 3 equal to 0. Subtract 4. This equals negative 4. Add 3. X equals 3. So you got two x-intercepts here. Negative 4 and 3. So the x-intercepts, and you do a comma to separate them. Negative 4 and 3. The x-intercepts are negative 4, comma 3. Now, vertical asymptotes, what makes the bottom equal 0? So vertical asymptote, you make the bottom equal 0. So you put x squared minus 4 equals 0. So it'd be x plus 2. Oops, I'm going too fast. X plus 2, x minus 2 equals 0. X plus 2 equals 0. X minus 2 equals 0. Subtract 2, x equals negative 2. Add 2, x equals 2. So we've got 1 at x equals negative 2. Got a vertical asymptote. We got 1 at x equals 2. So the equations of the vertical asymptotes are x equals -2, comma x equals 2. So x equals -2, x equals 2. Horizontal, which one has a higher power? Top or bottom is a tie. This one is a tie. So I'll write it down. It's a tie. So you do y equals leading coefficient in the top divided by leading coefficient in the bottom. So it'd be y equals 1. So it's going to be there. So the equation of the horizontal asymptotes is r y equals 1. Y equals 1. Nice work. Now plot the points. So we're going to plot points. I'm going to use the calculator. So you've got x and you've got f of x equals x squared plus x minus 12 divided by x squared minus 4. And so we've got -10, -6, -1, 1, 9, 11. 11. Second graph. So -10. That's 13/16. -6. 9/16. -1. 4. 1. 10/3. 9. 78/77. And 11. 40/39. So that's approaching 1. So -10 is 13/16. So that's way out here. 6, 7, 8, 9, 10. -6 is 9/16. That's right there. And 0 there. -1 is 4. So it goes here through here, then goes down there. -1 is 4. 1 is 10/3. So 10/3, that would be 3 1/3. So it kind of goes, it's not quite symmetric. And then 9 is, so it goes through here. It's 3, 4, 5, 6, 7, 8, 9. Not, they're just approaching 1 here. So it just goes closer to 1. So I'm looking for that graph. This confirms it. And so enter these in here. 13/16. 9/16. -1 is 4. 1 is 10/3. 78/77. And 40/39. All right. The graph, we just talked about that. But I need to see these better. So it's got, oh, this one right here. Okay. Uh-oh, slant asymptote. I'm about to be in trouble. Guess who didn't cover slant asymptotes very well? That would be me. So f of x equals x squared minus 49 divided by x. You might have to do long division here. Oh, man. I wish my teacher would have taught this better. Okay, so long division. So slant, asymptote. You got to do long division. So I'm going to do x divided by x squared. I'm going to put plus 0x minus 49 because there's no x there. So how many times does x go into x squared? It goes into there, or x times what gives you x squared? I'm sorry, x times what gives you x squared? X. So you're going to do x times x, which is x squared. And then that's it. Subtract it, cancels. Bring down 0x. X times what gives you 0? Nothing. So you multiply this by 0. Look at all this room this is taking up. And then negative 49 is going to be a remainder. So it's x minus 49 divided by x, but the slant asymptote is just this part. So the slant asymptote is x. I'm guessing that's going to be the same for everybody. Is y equals x. Y equals x. My bad. So the equation of the slant asymptote is y equals x. All right, let's try this one. X squared minus 49 divided by x. Graph. Yeah, it didn't. We have the same one. Yeah, I don't think it doesn't look like it will. Yeah. Well, it might have origin symmetry actually. Let me check this.
Yeah,
So
if you would multiply the bottom.
yeah, so we do yeah, I could do that. Which yeah, you're right. It will have origin symmetry. Shout out to Quaid. Got him. Well, it looks like it does. Because if you could opt to multiply the bottom, you're right. That's a good observation. So x squared minus 49 divided by negative x, which you could say is negative x squared minus 49 divided by x. The whole thing's negative. And then negative f of x is the negative of the whole thing, which x squared minus 49, which is the same thing as this. Okay. It's 49. Oh, I put the negative down there. So it does have origin symmetry. So f of x does not equal f of negative x, but f of negative x does equal negative f of x. So it's going to have origin symmetry. So it does have origin. And you can kind of tell, we got suspicious when we saw that, how it's kind of symmetric, the origin there. Okay. Am I ever going to finish this? Made this too long. Yeah, last one would be easy. The y-intercept, you just make x equal 0. I think it's easy. It's the average cost. Make x equal 0. So 0 squared minus 49 divided by z. Oh, no y-intercept. We haven't talked about this. That's undefined. Well, there's going to be an asymptote there, so there's not going to be no y-intercept. Because there's going to be an asymptote there. So there's going to be no y-intercept. There is no y-intercept. There will be an x-intercept, 2 of them. X-intercept, we make the top equal 0. Top equals 0, so x squared minus 49 equals 0. X plus 7, x minus 7 equals 0. So x plus 7 equals 0, x minus 7 equals 0, subtract 7, subtract 7. Now you could eyeball this. Add 7, x equals 7. So there are 2 x-intercepts. X equals -7, X equals 7. Or what? Actually, they just want you to list them. The x-intercepts are -7 and 7. Oh, don't put and, you idiot. -7, comma 7. -7, comma 7. Gosh. All right. And then can I get vertical asymptotes? Y'all know what that's going to be, right? It's x equals 0. You make the bottom equal 0. I'll prove it to you. So vertical asymptotes. So you make the bottom equal 0. So it'd just be x equals 0. Well, it can't do much else besides that. So the equations of the vertical asymptotes is our x equals 0. Now, for the horizontal, which one's got higher power, top or bottom, or is it a tie? Top. Yeah, top. Good. What is it when the top's bigger? None. Good. So the top's bigger. So there's no horizontal asymptote. So there is no horizontal asymptote. There is no horizontal asymptote. Okay. Plot this in your graph. So we're going to do the plot the points. So plot points. And you got x, you got f of x equals x squared minus 49 divided by x. So I'll go to second y equals, oh, what were my x's? -9, -6, 6, 9, 10. -9, -6, 6, 9, and 10. I've not been doing any graphing here, so this is bad teaching on my part. Macy just said amen. -6, 13 sixths, 6, -13 sixths, 9, 32 ninths, 10, 51 tenths. Now you could cheat and look at the graphs on the next one, but I'm not going to have time to. I'll try to do the last one here, though. 13 sixths, -13 sixths, 32 ninths, and 51 tenths. Jeez. Now graph it. We know what it's going to look like. It's going to.
Why are the why do the asymptotes look like that? So I get the vertical one.
The slant, it's a slant. It's a y equal to y equals x line. I didn't even been graphing this. That's what I was saying. This is pretty white trash teaching. So the slant asymptote's y equals x. So it's like an asymptote like that. And that's why it looks like that. Yeah, good question. And that's, as I said, I should have been covering that. And there's one here too. And so that's why those go. You divide by x on that. I'll look at it in a moment. 7. So it just kind of goes off like this. And it goes like this. Like 1, 2, 3, 4, 5, 6, 7. And then it goes like that. I didn't plot the points there. I'll look at this one. I'll look at it. I'm making a video between classes here. 24. All right. Companies plan to build. Y'all have a good day. Made and manufactured by X. The cost will be. And fixed cost. 300,000. Plus 200 for each bike. So C of X equals 300,000 plus 200X. So 300,000 plus 200x. The average cost function is you just divide that by x. So the average cost function would be just divided by x. Thank you. Divided by x. Just divide cost function by x.
Albert, I'm gonna
What's that?
one of these. I'll probably be right
Sounds good.
back. I just gotta do this last one.
Okay. 200x divided by x. Check answer. All right. Find interpret. Oh, I'm not doing all that right. Okay. Find interpret. So let's do C bar of 500. So I'm just going to plug 500 into here. That's 200 times 500 divided by 500. I'm going to do math frac here. Go to second mode to get out of there. Math frac. So 300,000 plus 200 times 500 divided by 500. That's 800. Okay. C bar of 12 parts. That's 800. All right, interpret it. So what that means is when 500 bicycles are produced, the average cost is 800 to produce each bicycle. All right, C of 1,000. So 300,000 plus 200 times 1,000 divided by 1,000. So I'll change the 500s to 1,000. This is not much fun. 1,000. 1,000. So be 500. So when 1,000 bicycles are produced in a month, the average cost would be 500 per bicycle. So when 1,000 bicycles are produced, it'll cost $500 to produce each bicycle. So your X goes here, and then your output goes there. So for 2,000, you just plug in 2,000 into the formula. I could change the 1,000s to 2,000s. So 350. So when you produce 2,000 bicycles, it costs $350 to produce each bicycle. Whoops, 350. Okay. So for 4,000, I'll get 4,000 for X. Change this to 4. Change this to 4. This is 275. So 275. So when 4,000 bicycles are produced in a month, it costs $275 to produce each bicycle. So when 4,000 are produced in a month, it costs $275 to produce each bicycle. Okay. All right, so now for the D, horizontal asymptote. So I'm going to write down the equation again. I'm going to look at this. 300,000 plus 200x divided by x. It's a tie. So when it's a tie, you do leading coefficient at the top divided by leading coefficient at the bottom. And so I'm not sure if they want us to write y. Y equals leading coefficient at the top is 200 divided by leading coefficient at the bottom, which is 1. So y equals 200. I don't know if they want y or c of x here. Let's see what they'll take. Y equals 200. Oh, no. Yeah, they'll take that. What does this mean? That means the cost per bicycle approaches $200 as more bicycles are produced. So as more you produce, it's going to approach the average cost will be $200.